Again, we are going to calculate for another model, that is linear regression. For linear regression model 1, that is linear regression, you have got MSE value as 5.18. I'm going to apply machine learning algorithm 2 for the same data. For the same data, I'm going to apply the second machine learning algorithm, which is non-linear regression. And there I'll calculate the MSE. There I have got only 4, assume. Out of these two, which is best? This is best. For my given data, how I can know this is best or this is best? How I can know? Until I try this one, I don't know. You have to try, and after that you have to check the value, then you have to decide. Now you are going to try with third machine learning algorithm, that is lasso. There is one more regression called as lasso regression. Now for that, MSE is equal to 1.2 only you have got. Now which is best for this data? This is best. How you can know that one? After applying that one. Without applying, by seeing itself, how I can say this is best or this is best? We can't say by seeing the data itself, we can't say that this is the best algorithm for this data. We have to try with all the algorithms and we have to try which is the best. Is that clear? So just yesterday, whatever the max I have done, the same thing, the same steps and the same values. That is theoretical part. This is practical part in the code. But these things are calculated in the back end is the same manual calculation was written. This was given in the mean square error. What is the back end code of mean square error? This is one of the def function only, which they have created, inbuilt function. For this, it is going to take 2 arguments. One argument is A, one argument is B. Their name is A and B, might be, who knows, but 2 arguments. And out of which the first they are going to calculate the A value, df, the A will be taken, and A minus B will be created a new column. How to create a new column, you know. That is df of E is equal to df of A minus df of B. Like this you are going to calculate. Once you got this this one, you are going to create a new column called as df of E2. This is a new column name I am going to create, which is nothing but df of E into df of E. Once I calculate the error square, that is the new column was created with error square. Finally, I'm going to calculate the mean of this. That is nothing but df of E2 dot mean. This is going to be written. This is the backend code of that one. The backend code is written by a human only. That is written by based on the max only. But instead of writing these many equations, it makes us very simple by writing one line of code. That is Python. Python libraries help us to reduce the lines of code. Is that clear? That's it. Sir, I want RMSE value. That is square root of this. Yesterday we have calculated the RMSE value as 2.275. Now I want RMSE. How to calculate RMSE means? For RMSE there is no function. You have to import NumPy. You have to import NumPy. I am importing NumPy as NP. In the NP, there is a square root function is available. NP.sqrt function of MSE. You are going to give the MSE value, and for this you are going to calculate the RMSE value. RMSE is equal to, save it as like this, divide and RMSE 2.275. The same thing what we have done yesterday, 2.275. Now, how the beta naught and beta 1 is calculated is clear. How it is calculating the MSE value also is clear. Is that clear? Now, when we are learning, remember, when we are learning, as you are a learning stage, you are the students and you are learning for the first time, then you have to take a simple examples. Directly, if you go into the complex examples and sir, I understand yesterday this class, sir, I am applying this one, sir, and I am not getting the answer, means you will only confuse. If you take simple examples where the max you are writing clearly and this one you are writing clearly, then you will get the more subject. How I got this much of subject means by practicing like this. By taking directly 200 records or 500 records at a time, if I do means I can't do manual calculation. Whatever the answer it is showing, I have to assume only. This is the correct answer. Okay. I have to feel myself, but I can't cross verify. I can't get the subject perfectly. To get the subject perfectly, you have to take a simple examples first. Okay. How you will understand this one means, if you go to a LKG student or first class student and you want to teach him the addition, how you are going to teach him 1 plus 2. First time you are going to teach him 1 plus 2 or 1 plus 3 or something like this. You are going to show one finger on the left hand, two fingers on the right hand, and this is 1 and this is 2. Adding of this is 1, 2, 3. Total 1 plus 2 is 3. You are going to explain like this. This much of simply you are going to explain for him. If you start directly example of 104 plus 99 is equal to 203. If you explain like this, what happens? Go and try. If you want, you can go and try. For the first class student, go and try this example. Instead of training of 1 plus 2, go and try this example. What their expression? For me also, same expression from you. For you, they are the students. For me, you are the students. So when you want to train the first class student like this, very simple examples, how you will train, in the same way I will train the simple examples. Instead of directly going to the complex examples. When I will go to the complex, when you understand the subject, you are going to apply the next example, next example, next example like that. You have to increase your level. You have to practice multiple times by taking different data. Now the same data, whatever I have taken is complete data. The complete data I have taken. Now instead of complete data, now you are going to take with respect to X-train and Y-train. Take the X-train part and Y-train part. Again, you do the same thing. That is practice you have to do. Right? So I am explaining, since it is a first algorithm, I am explaining very detailedly. Now the same way you have to proceed for every algorithm. For that you have to spend the time. Right? So the beta naught and beta 1 is calculated based on the formulas. The same formula was given in the backend code of the fit. Model.fit on the x comma y means this is the backend code. It is going to calculate first this column. It is going to create the column, this column. It is going to create this column. It is going to create this column. And it is going to calculate the sum. What is the backend code? Def of that function. Whatever the function, linear regression is a function. Linear regression is a function. Just it is a function. This function, you are going to use the fit. Fit means you are going to give this data as the input parameters. And now in this function, it has written with respect, first calculate the x minus x bar. For calculating x bar, first it is going to create the new one. X underscore mean is the column will be created. And it is going to calculate no need of column, just value only. So x underscore mean will be created, which is nothing but df of x dot mean. And whatever the value is going to calculate, it is going to store. First, this value will be stored. After that, y underscore mean value will be calculated. This value will be stored. After that, it is going to create a new column with respect to x minus x bar. After that, it is going to create a new column y minus y bar. After that, it is going to multiply these two things. Two columns multiplication, I have told you in the pandas how to create a new column, how to multiply with the two columns. Everything I have explained in the pandas. Now, these things you are going to just multiply. And after that, automatically for this particular column, you are going to apply the sum. And you are going to get this value. And it is going to store in the numerator, some name as n. Again, it is going to calculate this one. And again, it is going to calculate the sum. And it is going to save it as a denominator d. And beta 1 will be calculated as n divided by d. Simple. And it is going to return that value. Whatever it is in that function, if there is a return miss, it is going to return. If the function doesn't consist of any return miss, it is not going to return. It is going to process only, but it will not return anything. Okay, for example, I have created def sum a comma b is the function name, where it has to create a new variable c, a plus b. This one I have written, nothing else I have written. Completed, function is completed. No return, no print, nothing is there. Now sum of 2 comma 4, if you write, what happens? It will work, but no output will be displayed. Output will not be there, but cell will be executed successfully. This cell will be executed successfully. This cell also will be executed successfully, but no output will be displayed. Why there is no output? Means in this function there is no return or there is no print. Similarly, in this function also, whatever the fit function you are having, in the fit function, there is no return. So it is not returning anything. Separately, you are going to calculate separately you are going to ask the quotient value and intercept value. Is that clear, guys? Can I proceed to the next level of real-time data? Linear regression is simple. Yeah, this algorithm is a simple linear regression. Yes. Multiple linear regression also same way. Exactly. It is the same way. For that multiple linear regression, you are having x1, x2 and y. Now it is going to calculate the x1 bar and x2 bar and y bar. Now beta 1 will be calculated. First beta 1, here you are having the equation. What is the equation for multiple linear regression? Means y hat is equal to beta naught plus beta 1 x1 plus beta 2 x2. Now you are going to have two quotient values, that is two slopes, and intercept value will be 1. Sir, why 1 only? Because actually that is also 2, which is equal to nothing but y hat is equal to y, that is m1 x1 plus c1 plus m2 x2 plus c2. Now m1 x1 plus m2 x2 and c1 plus c2, you are going to take it as c3. Constant only, right? You can add the constant values directly. Some values of constant values directly you can add. So directly, since it is a constant value, I am displaying this as beta naught plus beta 1 x1 plus beta 2 x2. Beta naught only consists of these two constants values. These two intercepts already included in that. Right? Now, how it is going to calculate beta naught plus beta 1 x1 plus beta 2 x2. Now you are having x1, x2 and y. You are having like this. Now beta 1 value, how it is going to calculate this? It is going to calculate first x1 minus x1 bar into y1, that is y1, y minus whatever the formula you are having for the regression, it is going to apply for the x1 only. x1 and x1. And it is going to calculate the beta 1. Similarly, it is going to apply x2, x2. Then it is going to calculate the beta 2. Y will be same. If you write x2 into x minus x bar, it is going to calculate the beta 2 value. If you write the third variable, beta 3. If you write fourth variable, beta 4. Like this, you are going to calculate. Similarly, you are going to calculate the beta naught. For each beta naught, you are going to calculate at sum. All the beta naught sum is final beta naught. Is that clear? Multiple linear regression is multiple times applying simple linear regression only. Applying multiple linear regression, multiple times you are applying the simple linear regression is called as multiple linear regression. Is that clear? Now, so let us move on to the next one. That is, now I am going to take the complete project from the start to end. So that is first step. Total, you have to write the notes now. Okay. First you have to focus. After that you have to write the notes. Just focus and take the notes. These notes you have to write in your notes only. I'm not going to take the screenshot because these notes, these steps should be in your notes. Every time you have to revise. For every model, this is the same thing you have to do. So first, I'm going to write first focus. Don't write simultaneously. Because if you write simultaneously, what happens means I'm writing one sentence, you'll write another sentence. Which one you will register in your brain? So whatever the sentence I'm writing, you have to focus on that. You have to register only that sentence in your brain. Means just focus. First step. Step 1 is business problem understanding. You have to understand your business problem very clearly. This is your first step. Step number 2. You have to understand the data. Data understanding. Data understanding is nothing but, I'm writing clearly data understanding. What is the meaning of data understanding? Means understanding each and every variable. Understanding each and every variable very clearly. It is called as data understanding. Understanding each and every variable. So whatever the variable names are there, understand that variable name. So there's, for example, the variable name is sex is there. What is meant by gender? How many types of genders will be there? Do the research. If you don't know, miss, you have to go in the Google and you have to check. You have to check with each and every variable very clearly. That is your second step. Now, in this second step only, the data set understanding also will be there. You have to understand your data set, understand very clearly. Means, data set understanding is nothing but you have to check the shape. What is the total number of records and what is the number of columns? That is shape. And in that, how many variables are continuous and how many of them are discrete variables? And within the discrete, how many are discrete count and how many of them are discrete categorical. Understand each of them and take in a separate list. List of with respect to continuous variables as a separate list. List of discrete variables in a separate list. And understanding your data set is this one. And that is and df.info. You are going to do the df.info and you are going to check every data type and the column names, whether the column names are proper or not. Check the column names. Column names are very clearly there as per the rules. It is following as per the rule or not. Check the column name. So these steps are in the data understanding. Once this is second step is done, now we are going to proceed to the step 3. That is data pre-processing. In the data pre-processing, you have to do in terms of the first one is EDA. Understand the past data only. Don't do any manipulation. Understand your given raw data. Analyze the raw data. EDA meaning is analyzing the raw data. Analyzing raw data without doing any modification. Analyze. Apply the various plots. Apply value counts for discrete variable. Apply some kind of describe function. And whatever the things we are having, do that one. Pandas and Matplotlib and Seaborn. Using these 3 libraries, you are going to do the EDA. Analyzing the raw data. And in this only you have to identify how many missing values are there. How many columns are having missing values. How many columns are having outliers. And how many columns are having with respect to encoding. I mean discrete variables which you have to apply for encoding. How many columns are skewed distributed. Like this you are going to check how many. Analyzing the raw data only. Don't do modification. Is called as EDA. After that you have to do the next one is do the modification. That is data cleaning. You have to do the data cleaning. Already you have checked which column is having outliers. According to that, already this column is having the outliers miss. For that, you have to treat the missing values with median. If it is more number of missing values are there, you have to drop. Less number of missing values only you are going to replace. If more number, if out of 100 records, 800 records are missing values miss, you can't replace all the 800 values. This also you replace and you are predicting your value only. Yeah? So you should not do like this. You are replacing and you are predicting your values only. So that you have to do only the data cleaning with less number of records. That is less number of 20% records or 30% records means you can replace. Up to 20% of the records you can replace. Right? Now you are going to do the data cleaning and treat the missing values. Treat the missing values. And treat the outliers. After that, you are going to do the next step called as data wrangling. That is, do the transformations and encoding. Up to this, you have to do. This part is called as data pre-processing. After once this is completed, now you have to go with next one is train, test, split. You have to apply the train, test and split. You have to divide the data randomly. This is the next step. After this step, now you have to do the future scaling. Now you have to apply the future scaling after train, test, split. The future scaling should be applied only after train, test, split. If you want to do the future scaling miss, you have to do after only train, test, split, not before to that. If you do before to that, then it is called as data leakage. There is an interview question. What is meant by data leakage? Sir, what is meant by data leakage means that test data before itself you are knowing before train, test, split only you know that test data also. Na? Future scaling will be dependent on that both the train data and test data. If you do the future scaling before itself. So for example, you are having 1, 2, 3, 4, 5. In this is the test data actually. If you apply the min-max scalar, what is the maximum value? This in the train data, the maximum value is 4. If you do separately, this is 4. If you do combiningly, if you do the future scaling, the maximum value will be 5. So now, if you go with, so I'm going to do C. I'm going to explain very clearly. I'm going to take the example of 1, 2, 3, 4, 5. Now, before train, test, split, if I do the min-max scaling, what is this value is going to be is 0. that is 1 minus 1 divided by 4, 0. 2 minus 1, 1 by 4. This is going to be 2 by 4. This is going to be 3 by 4. Sorry. This is going to be 2 minus 1, that is 1 by 4, 1 by 4. This is 3 minus 1, that is 2 divided by 4, 2 by 4. That is nothing but 3 by 4. And this is nothing but 5 minus 1, that is 4 by 4, which is equal to 1. Like this you are going to get. This values is going to be 1, 0.25, 0.5 and 0.75 and 1. If you combine everything, this is the values. Now, for example, in this data only you are splitting the data. That is 1, 2, 3, 4 you are taking in the train. Test part is 5. Now, min-max scalar you are applying for this. Now, what happens? 4, first value will be 0. Second value will be 4 minus, 2 minus minimum value is 1. That is 1 divided by, this time 4 minus, divided by 3 only. 1 by 3, 2 by 3 and 3 by 3. Which is 0.33, 0.67 and 1. Now, if you apply before train test split the min-max scaling, the x values are going to be like this. After train test split, the x values is going to be like this. So, now the values has been changed, right? So, that is the reason you should not do the future scaling before itself. After doing that one, within the train data only, you have to do the future scaling. This is called as data leakage. So that doing the future scaling after train test split is called as, if you are doing the, what is data leakage is the interview question. What is data leakage? Applying the future scaling before train test split only. Before train test split, applying the future scaling is called as data leakage. This is the question and this is the answer. This is the data pre-processing. You have to do all these steps. Okay. All these steps, all the steps are there. All the steps you have to do before machine learning, before going to the modeling, irrespective of machine learning. Whatever the model you are going to apply, these things you have to do. Irrespective of whatever the algorithm. These are not going to change based on the algorithm. For that algorithm, you have to do like this. For this algorithm, you have to do like this. Nothing there is like that. You have to do before the applying any machine learning algorithm. These are the common for anything. Any algorithm before going to the modeling, this is common. Okay. So you can take the notes now from the step 1. All the steps you have to do before the modeling only. So I have explained very clearly this part, that is by using pandas, and this also I have explained by applying the pandas, and next I have explained this one using the matplotlib and seaborn, and this part I have explained you using the sklearn. So every part I have explained in this. Just you are going to apply for every project. These are the steps, one by one, one by one, one by one. This is called as ML pipeline. ML pipeline means machine learning pipeline means step by step. Pipeline means one after one. All the steps before modeling, that too, irrespective of machine learning, irrespective of algorithm, right? That one also, irrespective of whatever the algorithm you are going to apply, irrespective of that, we have to do all these first 3 steps commonly. You have to write in your notes very clearly. Don't take any screenshots, online people. Okay. Something, and it is very important, I will say clearly, write in the notes. Few things that is not that much of important means I will only make the screenshots. Earlier I have done multiple screenshots now. And this I am not doing the screenshot. Why? I am asking you to write because this is so much of important. Clear, guys? Step by step. In the same sequential order, you are going to come one by one. I'm going to write the step number 4. Can I start the step number 4? Can I erase? Yeah. You can please write. Online people, any questions? Yeah, what is the difference between fit and transform? Fit means calculate, transform means after calculation, updated values you have to replace. That is the meaning of fit and transform. Fit means calculation. Fit and transform means after that you transform, means convert. Convert the data. Whatever the data they have given, convert that one. That is 1, 2, 3, 4, 5. For this, what is the minimum value and what is the maximum value? Min value is 1, maximum value is 4. Okay. And you are going to apply the min-max scalar. Fit means it is going to calculate only the minimum value and maximum value. Transform. Fit and transform means it is going to transform this one to 0, 0.2, 0.25, 0.5 and 0.75 and 1. This is called as fit and transform. It has been transformed, converted. Is that clear? That is the meaning of fit and transform. Vaibhav, is that clear? Yes. Done? Yeah. Can I erase? Can I move to the step number 4, which is now the most important part? Step number 4. Don't write. Again, I will give the time. Focus. No, I'm giving my suggestion, but still if you want to write, miss your wish. My suggestion is focus on whatever I'm writing. No, sir, I will write my own. I will write only, then only I will understand this. It is of your choice. For me, anything is okay. Okay. Now, step number 4, which is modeling. Which is modeling. Modeling consists of 1. You are going to do the modeling. Here, the models we are going to prepare for each machine learning algorithm. We are going to do 3 models. For each machine learning algorithm, 3 models minimum. One is called as raw model. Raw model means without doing anything. That is data pre-processing you have done. Na? In the data pre-processing, you have to do the EDA and you have to directly apply the model. You should not do, you should not do the data cleaning or data wrangling. You should not do this one. Without doing this one, directly taking the data and directly doing the model. Without doing anything, directly if you apply it to the model, it is called as raw model. Or it is also called as baseline model. This is the interview question. What is meant by baseline model? Baseline model means by default, they have given the data for that data. We have not done anything special. None of the data scientist is not done the special thing. That is by default, the accuracy is available. Now, our work is by cleaning or by doing these things, we are going to improve the accuracy. Na? That is the specialty of the data scientist. Now, the raw model. The second model is called as you are going to do the data cleaning plus data wrangling. After that, you are going to the model. Then it is called as the model. Modeling. Okay. Before to that is called as raw model. After that, it is called as model. Now, here, whatever the model you are going to do, this model, I'm going to write this modeling will consist of 3 steps. It is going to have 3 steps. Step number 1 is import. Import the machine learning algorithm. Second step is save it into a function. Save to a model name. Save to some model name of your choice. Step 3 is model.fit. Fit on the X train and Y train. That is apply the model. apply the model. Apply the model on the data. Whatever the data they have given to that, apply this model. Means that machine learning algorithm you are going to apply on the data. Right? Here we are going to import the machine learning algorithm and we are going to save it in the model name and we are going to apply on the model, and we are going to applying on the model is nothing but fit on the data. What are the data? If you have given the extract means extract, text means extract. What are the data you have given? It is going to fit on that. Fit means the meaning of fit is nothing but applying the machine learning algorithm on the given data is called as fit. The meaning of fit is this. Whether it is a linear regression means linear regression will be fitted. If it is a polynomial regression means polynomial regression will be fitted. If it is a lasso means lasso regression will be fitted. Whatever the algorithm is there, that will be fitted. That to whatever the data you have given. If you have given a different data, sir, I want to select only this data, sir. df.ilog, I'm going to apply. And I'm going to select the row names as per my choice. For this only it is going to apply. Whatever the data you have given, it is going to apply for that data. Okay. So according to that, it is going to apply. That is called as modeling. And along with that, you are going to do the step number 5. The step number 5. What is step 5 is evaluation. Modeling and evaluation should be done simultaneously. Step 5 is evaluation. Evaluation is nothing but calculate the accuracy or error. Either calculate the in terms of accuracy. For calculating accuracy, first you have to predict. So here you are going to have the prediction. So prediction will be done using your model.predict on xtrain. You have to predict on your xtrain and model.predict on the xtext. You have to predict on the xtext. Both the things you have to predict because to calculate the train accuracy and test accuracy. Once you predict this one, now predicted values are there. This value is nothing but this value and this value is nothing but this is y hat of train. This is y hat of test. Predicted value on the test data. This is the predicted value on the train data. This is the output now y. Hat means predicted value on the train data. Now once the prediction is done, now the step 6. You are going to take the step 5 only. Sorry, not step 6. Step 5 only. You are going to continue with the last one, which is nothing but, I'm going to take in a different color. Okay. Nothing but calculate the error. Calculate the error or accuracy. Any one. Calculate the error or accuracy. You have to calculate the error between y pred train versus y train. This is the actual data and this is the predicted data for train data. Similarly, y pred test versus y test. You have to compare between these things like this and calculate this one is called as train accuracy or train error. If you compare error means error. If you compare accuracy means accuracy, whatever it is. Train accuracy, and this is called as test accuracy. Once you calculate this one, final conclusion, you are going to check whether the data is overfitted or underfitted or good model. You are going to check. And if it is a good model, that model you are going to submit. If it is a overfitted problem, you have to drop that particular model. You have to keep with you only. You should not share to others. This is called as check. Checklist. We are having multiple checklists are there that we'll discuss once again. So this is the common. Till this, it is the common. And whatever the test accuracy you are having, the test accuracy, the next step is test accuracy should be greater than your cross-validation score. Your cross-validation score and test accuracy, the test accuracy should be greater than or equal to your cross-validation score. It should not be less than that. You have to compare with your cross-validation score also. This is called as checklist. Checklist is One is this one. Second one checklist is whether it is overfitted or underfitted. Overfitted or underfitted. This is checklist number 2 or good model. Checklist number 3 is satisfying whether the business problem or not. It satisfies the business problem target. Whatever the business problem target is, that the target is satisfied or not. This is the checklist. Now you can take the notes. Step by step. And I'm going to apply what are the steps I have told you. The complete steps I'm going to do for the first project. Everything. And you have to take a different data set and you have to apply. Before doing that, first you have to understand the whatever the example we have done. You have to revise the same example and then you try on the new example. Yes, you can write now. For every algorithm, this is the same thing. For every algorithm, for every data set, this is the common steps. Tell me cross-validation once. Just we are going to take, because in the train test split, we are going to take with respect to random state. So different data we are going to get. So for one data, one score you have got, means for another data, another score you are going to get. That is the reason we are going to cross-validate. That is average score we are going to take. That is called as cross-validation. Now to do all these things, you have to attend all the classes. If you have missed one of the class also, now you will not understand anything of this. Automatically this part will be difficult because if you have missed Pandas class, you don't know how to create the columns. If you have missed the Seaborn class, you don't know how to make the plots. If you have missed the time test split class, you don't know how to split the data and what is meant by random state. If you have missed that overfitting and underfitting and cross-validation score class, you will not understand whether it is a good model or a bad model. If you have missed that machine learning introduction class, you don't know what is meant by predictive. If any one of the class, if you miss also, today's class or today application will be somewhat difficult, you will feel. Who will feel easy miss? Who has understand every class, understand. Who has listened, not only listen, who has understand, everyone will have, today's class will be very easy for them. Actually, machine learning is the deadliest part. But the thing is that we have to remember the fundamentals. Whatever we have done in these 2 months, we have to remember all the things. If you remember, miss, it is easy. If you don't remember, this is the difficult one, obviously. For this, hypothesis testing also involved now. Hypothesis testing also will come. None of them, whatever we have discussed, everything will see application. In the first project, we'll see complete application from the day one. So, if you are okay, I will start the project. If you want the time for preparation, sir, I will revise once again the concepts of please give us the time, miss. I will give the time and Monday we'll start the project. It's of your choice. Okay. So, if without understanding directly, if I continuing my code, miss, there will be no use. What is the purpose we are teaching is for students to understand and they have to get the job. That is the main reason and that is the thing which we are doing all these things. Yeah, how many wants the time and Monday they want to be started? They want to prepare? Oh, just raise online people and offline people. Just raise the hand. In offline, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. Offline. Okay, fine guys. So I'm giving the time for you. So when I'm giving the time, you have to utilize that one. The last week also I have given the time like this only. Hypothesis testing, once we have completed, I have given the time by cancelling the class. Today also we are going to do the same. Okay. Why the time I am giving is to revise the concepts. So when I'm giving the time, you have to utilize that one. Since you asked me, I'm stopping off the class for this. And from Monday, please make sure you'll have the concepts revision, every concept. I'm saying once again, each and every class, whatever we have discussed, I'm going to apply. I'm not going to miss one of the class also. Not even one class. hypothesis test class, descriptive statistics test class, probability class, uniform distribution class, whatever we have discussed, every minute class, whatever we have completed till now, each and every class I am going to involve. The first project. Okay. So in the next 20 days, we are going to complete the machine learning. And after completing the machine learning, you have to take the Kaggle. Okay. And our aim is in the Kaggle, you have to get in top 2 percentile. And I have to select you in my company. That is your target. If you have got in top 2 percentile, you don't need to ask me any questions. I'll not even do interview. Directly come and sit in my company. I'll pay the package of 6 lakhs. It's open. I'll not even ask the interview questions also. If you're okay, you can. I'll not even do interview. 6 lakhs package directly I will give. Right? What is your background? I don't want. No need to tell me the background. I don't want your name only. Then why I want your background also? Your background is BTech mechanical or BTech civil or whatever it is, degree or BCom or career gap, my experience. Forget everything. If you have Kaggle of less than 2 percentile and with respect to NASSCOM certification, directly come and sit in my company. The moment you complete, the same day I'm going to release the offer letter. Right? Sir Jyoti, sir, I haven't get the voucher of Microsoft exam. Please suggest any other exam for Python. Yeah, Jyoti, there are multiple exams are there. Yesterday, actually, okay, first you please complete this one.